So good morning to all. Today's topic is basics of serverless services in AWS. So AWS offers wide variety of services, like we see in that 5 categories, which is of compute services, network services, storage services, database services and security services. Apart from the 5 categories, we have serverless services also by the AWS. So in this session we will see an introductions about fundamentals of serverless services in AWS. What is serverless? So first of all, we need to discuss about what is the meaning of serverless services. So these serverless services are mostly suitable for short running and stateless computation applications. Serverless in this regard means you need not worry about infrastructure management and maintenance and categorization. Like many services are defined in a serverless, like you need not worry about its native platform. AWS itself can be taken care of entire maintenance of infrastructure what you required for. So here developer need to concentrate only on the code, need not worrying about underlying platform where it has to be run or where it has to be executed. That is called as serverless. So serverless means that you cannot think that it is not having any server, but you can think that serverless means you or developer need not worry about any underlying infrastructure management. So you have to concentrate only on your code so that you can execute an environment where you require. So that environment will be provided by cloud itself. So serverless services are more in AWS, which can be defined like the basic serverless compute service, you can say it as Lambda. So like that you have many serverless services offered by AWS. And what serverless, where it can be used for? Serverless is mostly used for short running stateless computation applications, and mostly which can be used for event driven applications, where you need not worry about auto scaling and load balancing. It can scale up and down automatically. And what is the charges for serverless? The charges actually for millisecond. So how long you are using for that, you have to pay for that only. So this is where we are using the serverless applications. And evaluation of serverless, if you see here a diagram, you can have different type of applications like software as a service, infrastructure as a service, platform as a service. So these services, how it can be evaluated as in serverless, and basically you have a bare metal like hardware like VMware. It can be support an underlying hardware that is to be accessed by any of PaaS and IaaS applications. So initially there is a bare metal at the top level infrastructure as a service, which can be accessed by a platform as a service. So now finally you have container orchestrations like Kubernetes, Docker, so where you have been run your all microservices that can be managed grouply by a container. So this is the evaluation of serverless. When serverless was entered, so the serverless was entered after container orchestrations, like past applications are there, you need not worry about any platform. So you have a code to be run, so ready-madely the platform is available to you. So where this PaaS and container orchestrations that evaluate the serverless. And what is serverless deployment model means? So you need not mean that there is no servers or you have no worry about what the server management and all. You have to run only the code based on your demand. So serverless deployment model, you can see here, you just have to concentrate on your code. There is no need to maintain of any servers and any virtual machines. So that is the meaning of serverless. So you have to run your code based on your request base. And why serverless is more attractive? The reason for the serverless which can be more attractive means which drives an infrastructure cost savings, and it have many virtual machines that can be run on background, and there are containers, so like that you can deploy your code very easily within a milliseconds. There is no maintenance cost, and dramatically which can be very faster and cheaper and easier to maintenance compared to the server oriented resources. So this is why the serverless are more attractive. And what serverless is good for, and why not it is not good for long running jobs? The main reason that serverless is good for is it is stateless and event driven services. Suppose, say for example, you have an S3 bucket and you set a permissions to whom the S3 bucket access was given. So unfortunately your credentials was taken by other customers. So like where you have been maintained the microservices in terms of a mobile backend. So like here your credentials has been taken, so that whenever anyone try to delete your file from an S3, so immediately you can get an event triggered by a serverless service called as Lambda. Then you can be notified via a mail or some text messages. So like this, based upon an event and which can be stateless, you cannot worry about any stateful management of REST services or all. So you just concentrating on your code, and all these things can be run on the back end. So like it can be mostly used for microservices, mobile backends, bots, machine learning interfaces, IoT applications, and stream processing exclusively. So these are all the services where it has been good to run all the services over a serverless service. And serverless service is not good for long running jobs because of serverless. Like Lambda, if you can take, it can be work for short workload. Short in the sense the time is 15 minutes like. So it is not good for long running jobs, because like databases with heavy data to process, it takes more than 15 minutes for that. And deep learning training, heavy duty applications, video streaming, which is not suitable because of long running jobs. So in this we can conclude that serverless services are good for short running and event driven stateless applications. So serverless is not good for long running jobs. And what are the current platforms for the serverless? So these are the current platforms where serverless services has been used. So see that you have AWS Lambda, Kubernetes, Google Functions, Red Hat, IBM Functions. So these are all the services where it can be run over serverless platforms. So these are all current serverless platforms. So here serverless database is also there, serverless compute service also there. So serverless database, we can say the DynamoDB and Amazon Aurora. So where you can see that serverless compute service, best example is AWS Lambda. So these are all other different cloud services where all this can run over a serverless service. And this serverless service in AWS, the first serverless service in AWS is compute service, where AWS Lambda can fall under that. So AWS Lambda, which is an example for serverless compute service offered by an AWS. So which is an event driven serverless platform where you need to concentrate only where you have to run your code, which platform you are selecting to run your code. You need not worry about like EC2 instances you are taken to launch a virtual machine. You have to configure, like you have to select an operating system, you have to select an AMI, and you have to select virtual private network. So like that, many things you need to configure where you are moving for EC2 compute service. But in the same fashion, if you are working with serverless service, user need not worry about that. You just concentrate only on your runtime code where it is to be executed. So that is Lambda function. And run your code without managing an infrastructure. It automatically executes execute a code where at any scale thousands or hundreds of requests per second it can take, and optimize the code execution time, so that memory optimization will be happened by using the Lambda function. And see that in this example you can see how Lambda works. Suppose, say for example, a photograph was taken, how it is to be processed. Now I need to upload this photograph into an S3 bucket. So whenever a photograph is uploaded into S3 bucket, a Lambda is triggered, means that an event can be happened. Like uploading is here as an event. So once an event can be happened, Lambda runs an image code. Suppose here my photograph is taken as in large size, I need to decrease the size, so that once an image is uploaded into S3 bucket, that event can trigger a Lambda function. So here Lambda compute function can run, so that compute function can decrease the photo size. See that here photo size will be decreased. So this is a best example. So now we have a doubt here, how long the Lambda is working for. You cannot assume that photograph conversion like resize cannot take more than 15 minutes of time. So such type of short workloads, Lambda can be preferred, very better option. So this is how Lambda works. So Lambda can be triggered whenever certain event can be happen. Again, one more example here. Lambda can be triggered whenever a file is uploaded into S3 bucket or file is deleted from an S3 bucket. So like that you can trigger a Lambda based upon events will be happen at any moment of time. And the next service is AWS Fargate service. This is the other AWS serverless service. So it is a container orchestration service and Kubernetes management service. So AWS Fargate is serverless compute engine. You have to focus on your applications without managing the services. So Fargate can run container services as well as Kubernetes services. It cannot just like a Lambda function to work with any S3 or any other. So Fargate can be most suitable to run application from the container services as well as Kubernetes services. And so in this Fargate you have to take, like here in this previous slide you have seen that Elastic Container Services. So how Elastic Container Services can be run by AWS Fargate? So first you have to deploy and manage your application. The next one, monitor your applications by using CloudWatch, the second one. Then the third one, Amazon ECS tasks, Amazon EKS, Elastic Kubernetes Services pods to run on their own time. And this Fargate scales, compute and closely match it to the resource requirement without over provisioning the resources. So before a Fargate runs, first you have to manage your Kubernetes services and Elastic Container Services that can be taken run as EKS pods. So you have to pay attention so that Fargate can scales everything. It can be closely monitor all the applications whatever you are running from your ECS as well as EKS pods. And Fargate is a container compatible service as well as Kubernetes compatible service. See here how the Fargate works. So without Fargate what happened, with the Fargate what happened. See here, without Fargate you have to build your container applications and you have to run your container application when it has to be executed by a compute EC2 instances, and the provisioning of resources which are necessary to manage all these EC2 instances and run both the applications and infrastructure. So based upon this time where you have been run the number of applications by the EC2, you have to pay for instances. This is without Fargate. Now see here with Fargate, the difference clearly shows here. With Fargate you just concentrate only on your build container images. So after that you have to define what is the memory and compute resources you require. Later on the applications will be run, that can be taken care by the Fargate. You need not worry about isolate applications from different virtual machine, or you need not worry about any provisioning on management of computing and memory resources. You just define what you require, what is the requirement to run your container images. You just specify that one, so that AWS Fargate will taken care of everything. So here the thing you are less compared to with Fargate or with Fargate is you need not manage any virtual machines differently. You can be isolated and provision of management of compute and memory resources. So here also the same, you have to pay for requested compute resources where you been used. So here you have to pay for entire EC2 instances, how long it was running. So that is only the difference you can be seen here without Fargate and with Fargate. And the next one is, the next serverless service is Amazon Event Bridge. So Event Bridge can connect AWS services like software as a service. So it is an application integration service where different applications can be deployed, because of to build loosely coupled systems and event driven architecture, you can integrate multiple services together to deliver and transform without managing or provisioning of servers. So that is called as Event Bridge. So Event Bridge is an example for application integration service. So where you can integrate different loosely coupled systems together to manage millions of tasks as a single resource. So that is application integration service, example called as Event Bridge. How the Event Bridge works? So Event Bridge, the name implies it is a serverless event bus. So you can filter, transform, route and deliver request based upon the events can be happen. See here in this example. So in this example there is an event bridge an event source where the event comes from. So these are where different sources where you can get the event, like AWS services, custom apps, software as a service apps, microservices. So many of these services can generate an event, so that it all falls under event sources. And this is an event bridge, and these are all the compute services where you have to take the event bridge applications to be clubbed together and run as a single source. So these are all the compute services or targets where the Amazon event bridge has to be given as an input for that. So event source is there. So this event source is having different partners like default bus, custom bus, partner bus. So whenever event is to be happen, it archives all the events so that it is given one by one to replay for that. So which is registered by using schema registry. So how the events can be processed? Events can be processed by using setup rules, and it is also having a filter rules to set the targets as well as the events. So once the events can be happen, it is to be categorized any one of the three according to the rules mentioned. All this can be given as an input for the other services, other AWS services, mostly for application integration services like SNS, SQS and Lambda service for executing your events. So this is like event bridge can be work. So the input for the event bridge is the event sources where the events can be generated, and the output is given to an AWS application integration services. So not only here it was limited, you can take any application integration service. So this is how event bridge can work. And the next one is SQS, simple queue service. So what is the simple queue service? So in this example you see that many events has been happened when the events has to be processed. So simply here we are using SQS service, simple queue service. So this queue can be used for decoupling the applications. Why? Because entire large application is divided into many number of modules. So each module can be placed in one sector in a queue. So queue can be process that request according to the arrival into that queue. So here event processing can be done by using SQS, simple queue service. So as well as SQS can be used for decoupling your applications. And here this SQS is also an example for serverless service. It can scale elastically and cost effectively without planning and pre-provisioning the databases. And how the SQS work? See that here a producer is sending many messages. This SQS is a fully managed message queuing service. So here SQS based upon the type of application you can use. So here producer producing the messages, that messages can be given to the consumers. So this is the just a simple application. Suppose say or ordering or customer messages, so you have to request an order, that orders will be processed by using SQS in terms of market analysis or online marketing. So like that depends upon the scenario where you've been used, the SQS context will be changed. So this is an example, just like a producer is producing the messages and this can be given to the consumers. How this can be processed? So this can be processed by maintaining a queue in terms of reliable queuing service. So where the message will be available until consumer can consume it. So once the consumer consumes the message is deleted from the queue. Suppose say what happened if consumer is not consuming the messages, it will be placed, the consumer not consuming messages all will be placed in a dead letter queue. So this is called as dead letter queue. So your message will be retrained in a dead letter queue for the 14 days. So after 14 days the message will be defaultly deleted from this queue. So that is the feature offered by SQS. So where the dead letter queue is having a dead messages which not been given to the consumers. So this is like SQS works. And SNS, Amazon Simple Notification Service. So this is like a notification system which can be well worked with integration of Lambda function, which can be taken as pushing message service, where this push message is given to all subscribers of the SNS. It cannot give just like the messages like to anyone, whoever is subscribers for that message, so that persons only can get the messages from the SNS. So the name implies it is a simple notification service. So it is used for pushing the message for software applications between the endpoints and clients. How SNS works? See here, this is an example. The publisher is publishing a message, an SNS filter is there. So SNS, every message has been defined its own topic. Suppose say for example, student is one topic, customer is one topic, employee is other topic. So messages can be sent to SNS based upon the topic. See here, anyone can send a message. For every message we have to generate one topic for that. According to the topic, the messages can be filtered and that messages will be given to appropriate service where we are running our applications. So here also it is managing a dead letter queue. So if dead letter queue which is used for reprocessing of data, and it can get the messages which are unavailable to the end users. So this is how SNS works. So SNS, the main here the thing is you need to subscribe. So these we can say all this part we can call as subscribers because they are receiving the messages from the SNS. Why? Because SNS can be fully managed publish and subscripting messaging system based upon event. So what is an event here? A publisher pushing a messages, so that we can call it is an event happened. So once an event happened, that can be categorized into topic. So to whom the subscriber can get the message, it can be depends upon type filtering, you can use that. So subscribers may be either lambda functions, SQS, Kinesis, HTTPS, emails, or you can take mobiles also. So this is how SNS works. And data store. The best example for serverless data storage service is S3. If you see for S3, it provides unlimited storage service. You cannot manage any infrastructure. You just create a bucket and you have to upload your file. Nothing you can be managed like under your control. AWS itself will be taken care of all the underlying maintenance of how many buckets you need to create, and underlying bucket structure, where it will be saved, how the data will be replicated in 3 different locations. So all this can be taken care by AWS itself. So the best storage example in serverless by S3, Amazon is S3. How it works? You know that how it works already we seen in the previous classes how S3 works. So these are any type of file you can put into an object form into the S3. So any type of file, you can take videos, you can take graphs, you can take log files, or you can take any archival purpose like backup purpose. You move all these type of files in terms of object to the S3. So for S3 you have to create a bucket. So S3 you have many options like control access to data, like it may be publicly available or privately, and different storage classes are there like one zone IA, infrequent access, glacier, intelligent tiering, standard storage classes, and 3 replications are available defaultly, and the VPC where your S3 whether it may be private cloud or public cloud, and the secure data. So these type of storages is available unlimited capacity by the AWS as a best example for S3. So why S3 data? S3 data can be used for analyzing the data. You can take S3 data to provide an intelligence or to provide an analysis, or you have to take a conclusions drawing from the machine learning tools. So this is why S3 was used. And the second one is Amazon Elastic File System. So this Elastic File System, like we seen, EC2 is having 2 different storages like EBS and EFS. Elastic File System is a file storage or network file storage system. The same files whatever you kept in a network that can be shared between number of virtual machines. So when the situations this EFS can be used, if many virtual machines wants to work on common file, you have to take this Elastic File System. And come to the next database called as DynamoDB, so which is a fully managed NoSQL database and which is based upon key and value. So you just need not like RDS, you can save the primary key, secondary key, like that. All the data are related in an RDS, but in DynamoDB it allows unstructured data can also be placed. But how unstructured data can be retrieved? It can be retrieved based upon key and value technique. This is Amazon DynamoDB. So that's all about these serverless services. In this session we seen about Amazon S3 as a simple storage service, and serverless services, SNS, SQS, event bridge. These are all examples for application integration services. Thank you.